This tutorial is designed to help you calculate kinetic energy and gravitational potential energy. Kinetic energy is calculated by this formula, mv squared over 2. Gravitational potential energy is mgh. Let's break down the formulas a bit. This m references mass, and it must be measured in kilograms. The v would be velocity, frequently called speed, in the context of a problem, and that's got to be in meters per second. Gravitational potential energy. Okay, the m, again, is mass, measured in kilograms. G is acceleration due to gravity, and that is measured as 9.8 meters per second squared. And then h would be height, which must be measured in meters. Once you have your units right, you're ready to calculate. Also know that all energy is measured in units called joules. We abbreviate that with a J. Know that 1 joule is the same as 1 kilogram times meters squared over seconds squared. We're going to use this later when we begin to cancel some units. Our first example is kinetic energy. So we know that we are solving for kinetic energy. So let's write the formula. And now let's plug in our knowns. We know the mass, that's 65 kilograms, and we know the speed, that's 2.5 meters per second. According to the formula, that's got to be squared, and then that whole product divided by 2. Let's continue with the math component. So 65 kilograms, 2.5 squared is going to be 6.25, but we must also square our units. So that's going to be m squared over s squared, again, divided by 2. Moving on. 65 times 6.25 is going to be 406.25. We've got the numbers taken care of. Let's put in our appropriate units. We have kilograms times meters squared over seconds squared. Now we're going to divide this by 2. When we get to the end here and we do our division, 406.25 is equal to 203.13, but we need to include our units, so that would be kg times m squared over s squared. If you recall from the first slide, this right here is the same thing as a joule, so we can rewrite our answer as such, 203.13 joules. It's much less to deal with. Let's do a GPE example. Here we want to know the gravitational potential energy of a light that has a mass of 13 kilograms and it's 4.8 meters above the ground. Let's plug in our knowns. The mass would be 13 kilograms. In the previous couple of slides I told you that G is 9.8 meters per second squared, and then we end up with the height, which is 4.8 meters. When you're calculating GPE, go ahead and calculate all your numbers straight across, just mathematically multiply them, and we get 611.52. So we're done with all of our quantities. Now let's deal with our units. We can bring our kilograms down. Now we need to look and see what happens when meters is multiplied times meters. Okay, you get meters squared, so that's times meters squared, and then of course we have to have our little denominator here, and that would be seconds squared. Recall way back at the beginning when we said right here that 1 kilogram times meter squared over second squared is the same thing as a joule. That applies right here, and we can rewrite our answer as 611.52 joules.